So for the first part, the overview. Now, before we even talk about the planning or everything, let's talk about the protocols first, the sampling and planning protocols. Now, why do we even need to start planning first? Now, I mean, for obvious reason, because if you don't plan, for sure failure will come. If a failure can come in so many ways, especially when you go to something that you're unknown of. Now, for example, number one, before you even go, for sure you are going to know what is your objective. Kan? Because if you don't go and go there, what are you going to do? How are you going to do it? When exactly you're going to do the sampling? There are so many questions that hits you. So before you even go and have a physical movement, a trip to go and collect a sample, you must plan. You can have to plan as detailed as possible. Yeah. Because number one, even if you don't plan well, most likely the sample that you collected back is not representative of the actual sample that you want to know the quality of. So once you bring it back, there is some error here and there. The most important thing is when you collect your sample, are you collecting the sample as it should be? Kan? You see, when I say as it should be, kan, it's very subjective. Should be based on whose standard. You see, standard is very important because when you use a standard here in Malaysia, it applies in Malaysia. But when you go to other countries like US, UK, or maybe even India, their standard may be different. There is no one standard that fits all country. Every country may have their own standard that is tailor-made for that country. So be careful, you know. But it's quite safe to say lah, you for sure lah, I mean quite sure lah, you're going to stay in Malaysia and work kan. So whatever standards that you want to use for sampling, Malaysian standard lah, yeah. Okay. And then of course the outcome of this planning. Because why? I mean, when you want to sample water, for example, you cannot take the procedure for air to go and sample. So the outcome of it is like you need to know what medium that is suitable. You also need to know what pollutants or contaminants you're aiming. Because when you want to sample and want to analyze heavy metal content, for sure they are not volatile, betul tak? You can't really use the standard for VOC and analyze heavy metal. So these are the things I need to make your mind clear lah, yeah. So planning, what is the reason? The reason is to develop the outcome of this planning. So the outcome of this planning is the development of data quality objective. So these are the objectives that defines the quality of your result. So where does the quality comes from? From a proper sampling plan. Yeah. So let's go to these 5 objectives. I'm sure you have seen several of them. Number 1 and number 2, no need to explain further. Precision and accuracy, you've learned this so many times. If you're not sure, there are things that you can refer. But I want to go in detail lah. Number 3, number 4, and number 5. Okay, so number 3, representativeness. What does that mean? That means if you want to collect one sample, that sample have to represent the environment that you have collected. Like for example, if you want to collect water sample, that is one of the tricky part. Because what? When you collect the water sample, especially in river, you only collect the water at that point and at that time. Because why? River keep flowing. If you after 1 hour, you go back to the same location, you go back to the same location and you sample the water, can you say is the same? The answer is no. Because why? It's after 1 hour, water keep flowing. So after 1 hour, the water quality may not be the same 1 hour before. Kan? So that is the example that I'm trying to tell you here. Representativeness is something that you need to take consideration, especially when the medium you want to sample is changing very rapidly. So the example I already given you, water sample. So apart from water sample, it's air sample. Yeah. And then number 4, the comparability. When we talk about comparability, is that when you have the data or the data that you collected from a sampling plan for a sampling project, is it comparable to the standard or maybe even the data that you have from another location, for example? So how do you make them comparable? Now, comparability is so important is because of course lah, you need to know how polluted you the how polluted a certain medium are in the environment. So of course you need to compare something that is standard, like for example, in a government agency like Jabatan Alam Sekitar, they already have like a certain level of pollution, permissible level, they call it. Kan? So in this case, if you want to compare to those so-called permissible level, you also need to follow exactly the same way that they collect the sample and also the same way that they analyze the sample. See? Okay. So Shazad, have any questions?
Yeah.
If not, you have to answer. Okay, she's not hearing. Okay, good. Okay, then. So coming back to the point number 5, the last one, the completeness. Completeness means how complete are you when you are carrying out this sampling plan and analysis. So this is what you need to like look at, because why? If there are like sampling the procedures that you are incomplete, that means you cannot use it. Like it's not applicable, because why? Your data that you have collected without a complete procedure cannot be used at all. Okay? Because it's not it's not representing. I mean, the data that you collected from an incomplete procedure cannot be like cannot be assumed to be accurate. So that has a lot to do with the accuracy, because why? It makes people doubt whether the data that you derive is indeed accurate and representing the sample that you have. Okay? So now moving on. Now just now is more of the objectives, what you need to achieve when you're developing the sampling plan. Of course, you want to have a data as perfect as possible. So those 5 objectives are the one that defines the quality of your data. Now moving on to the next part. Okay, now the next part is we're talking about the personnel who are involved in the sampling plan. Now I think probably you can use this entire diagram. um, you can use this entire diagram to plan your sampling plan. Now, I know that you have like 80 people around you trying to develop this sampling plan. Now, when you have your breakdown, who are the director of the project, who are the person who is involved in a certain role in this entire sampling plan, I think probably you can refer to this diagram. Yeah. So there are many personnel involved in this. It begins with the manager, the head, I mean the so-called the head of all these so-called projects. So you need to like plan up um, what are the things that you want to achieve, how do you want to achieve it, and also one more thing, the cost consideration. So project manager is not there to like plan personnel. Costing is another thing that the project manager had to think of. Yeah. Because why? The reality is like this. If you want quality, okay, hmm, um, can you guys not touch anything? Because suddenly somebody take over my presentation. Okay, not touch, don't touch anything. You now lost altogether. Okay, never mind. Okay, for one more time, you guys don't touch anything. Can you not? Because I'm presenting halfway, somebody take over my presentation. Now I have to restart. Okay. Okay. Don't touch anything, yeah? Let me finish first. If you want to ask me question, you just switch on your microphone. Okay. Okay. So I'm talking about the project manager just now. I was talking about how what is the role of project manager. So they have to consider quality versus cost. In which after this I'll elaborate lah, yeah, quality versus cost. So under project manager, of course, there are so many people helping up in this case. There are like people from the sampling department. So they can be a lot of people. It can be just a general personnel who goes there, collect the sample using the instruments that's given to them. But sometimes you can go even beyond that. You can also employ specialists in the certain field where sometimes this personnel cannot cover. Like for example, the field engineer. Now, field engineer can be those people from various backgrounds. It could be from mining engineer. It could be from soil structure engineer. It could be geologist. It could be soil specialist. It could be even air quality specialist. Anybody that you think fit and should be there to consult you. Because why? Usually those field personnel, they are there and they are usually trained as chemists or people like you lah. We have just surface knowledge on how to handle environmental samples. Because sometimes when you go to a very specific site, they may have a very specific problem that you have no expertise in, which you should also consult with these people. So those are optional. But frankly speaking, Laya, frankly speaking, in sampling, there will be field manager, a manager that has slightly more information than the personnel, the technician, like we call it, the technician, and then they are there to like plan all the entire field trips, the sampling plans a little bit, they contribute, but above all they are there to supervise, yeah. So they probably have one supervisor or maybe field manager, field sampling manager, to control the activity and also the operation of the sampling, which will be conducted by many field personnel. So these field personnel are technician lah, you call it. Those are the people like you yourself lah. Fresh graduate, no work, and then you want some jobs lah. So these are the tough jobs lah. And it's quite safe to say lah, for those who are going to conduct internship later in any uh, environmental companies, you guys will be these people lah, yeah, field personnel. Yeah. Well, it's still work, kan? So you have to do the job. Okay, now after you collected the samples, then only you transfer. So in between here, this arrow, between sampling and lab analysis, sometimes there's one more. Well, at least this arrow should have one more person, like, given that the current condition right now. You can say these are the courier service provider. The courier service provider could be many. It could be Post Laju, it could be JNT lah, for those who are buying a lot of things from Shopee, so you know lah, these guys. But it's optional. Again, this is optional because what? You probably don't have the time or the manpower to do all the transportation. You can employ, you can. Uh, but sometimes you can also like use your own service, like you can employ a driver. So these are the people who what we call the transporter lah, yeah. Yeah. Okay, so after the sample is transported, then you move on to lab analysis. So this is where all those people enjoy the aircon, not like you. If you finish your degree, then you're going to be in the sampling, in the site, collecting samples. Then you transfer to these people. So who are these people? Obviously, they're chemists. So these are the analytical chemists that receives your sample and then they analyze according to the standard operating procedure as outlined by the methods itself. So these are the ones who is doing all the hard work inside air conditioned room. Well, don't blame them. Yeah, these chemists, guys, when they do work, they have to be working in air conditioned room. Do you know why? Okay, let me tell you straight away lah, yeah. Because most of the standard operating procedure, once they are collected, even when they are waiting to be analyzed without preservation, they are going for analysis. Most of this analysis has to be conducted at 25 degrees Celsius. So exactly aircon temperature kan. Unfortunately, these are the facts lah. For those of you who did not enroll bachelor degree in chemistry, sorry to say lah, you guys are going to work in non-ideal condition. The chemist will, because this is what they should be working under. Yeah. Okay, done. Now, after the chemists have analyzed that, you have all those raw data. The data, like for example, the pH value, the EC value, like the concentration of a certain analyte. So these are raw data. They haven't been interpreted yet, but they will be transferred into data analysis or statistician. Now, sometimes the chemists also do it, but most of the time they channel it to some statistician, because we're not talking about 10 data. We're probably talking about several hundreds or even thousands of data. pH value, several thousands. When you look at it, you ask yourself, what is that? Yeah, correct. What is that? Because we are not statistician and we cannot see anything. But once it is channeled to statistician, then they will be able to see what are the trends, yeah, the trends against certain environmental factors. Or maybe in fact, they're going to analyze whether these data are significant, or some of these data, statistically speaking, they are important for decision maker. So why statistician is here? Because they need to make a very significant decision. So when I say significant, I think you already learned statistics. What defines significant? Remember, the p-value has to be less than a certain number. Yeah, that's why. You cannot just say that, oh, based on this data, I felt like. You cannot. You have to be very certain. So the significance of data is calculated, and these are calculated by statistician. Okay, so once you have all the data sorted out and figure out what is that, then only you channel it to the data user. So this data user could be so many people, but most of the time, these data user will be the parties that funded this entire project. So these parties who have money, such as, number one, the government agencies that monitor environmental quality, such as Jabatan Alam Sekitar. Well, probably not Jabatan Alam Sekitar, is the Ministry of Environment and something, new name, sorry, cannot remember. So the Ministry of Environment is the one who can funded this one, or a certain company. So because why? Because some companies, like for example, the property developer, they will need to develop a site, but before they're allowed to do so, the government usually will ask them to do EIA. So EIA would definitely have everything of this. They need to send people to the site, take sample, analyze A to Z, and then come back to the government. So these are the people with money. Like it could be from government, it could be from private entities. Yeah. Because why? These are the ones who need this data to make proper decision. So you can see that the entire flow of this project, planning and sampling. But one thing that I forgot, QA and QC specialists. So who are they? They could be a team of several people appointed by the data user, or probably appointed by the project manager. I would say that it's probably appointed by the project manager itself, because usually data user, they just ask project manager how much they need to pay. They don't bother about the appointment. Because why QA and QC, I believe you should have learned in analytical chemistry before. QA and QC are two different parties. QA talks about quality assurance. QC talks about quality control. QA is more about management of the quality. QC, the technical side that ensures the quality of your analysis. So many people inside here. So you need to plan up lah, yeah. This is the so-called the summary lah. Of course, you can see there are detailed description on what roles and responsibilities of each of these personnels involved in the sampling plan. You can add, you can edit, you can cut out if it's not related. So this is a summary. You can look at it later. Yep. Okay, now coming back to the data quality objectives that we discussed earlier. What are the steps that you can use to ensure data quality objectives? There are 7 steps. So it begins with step number 1. State the problem. define the problem, identify the planning team, examine budget, and schedule. So I think this question usually is addressed by the head of the project. So you can see the project manager as you can see just now. So these are the planning stage, which that's why I say I need a, a project director from your group, because if not, then this will not going to happen. So it begins with the problem. You have to define what are the things that you need to see, and then see your resources. What are the resources that you have in terms of money, manpower, and also one resource that people always forget: time. Do you have long time to do this project, or you have very short time? You see, things can be done in very short time if you have a lot of manpower, which you have 80 members, and what you don't have is money lah. Money you can say is zero lah. Well, you don't need money because university have the resources. Well, you still need some money. So in your sampling plan, you also need to define which are the areas or the analysis or the sampling plan that needs money, because you cannot do things without money. To start off let's start with the sampling. You go to the site, you collect soil sample or you collect water sample. Where do you want to keep it? You cannot just use your hand, tadah, and then bawa balik to lab kan. You have to have plastic. Plastic is money also kan. Nothing is free. So you have to buy plastic. Now that is even one. Now that is only a starter. So you can think from the beginning until the end of the sampling. What are the costs that involve? You have to think of it. Yeah. So nothing is free. You have to plan. Number two, identify the decision, state decision, identify study question, define alternative question. So these are the so-called the problems. Once you have identified the problem, let's say for example, you want to find out what is the level of pollution in a site, water ke, soil ke. Once you have defined that there is a problem, suspected problem in the water quality, of course then only you come to the decision. Now, when it comes to water quality, kan, there are certain parties in Malaysia, actually several that defines the procedure and also the standard that to be used. So if you're talking about environmental quality, that usually falls under Jabatan Alam Sekitar. But if you talk about water quality for drinking purposes, that falls under Ministry of Health. So you see, there are certain things that you need to make sure, the jurisdiction and also the decision, you have to make a smart decision to pick which standard that you should have used. Because otherwise the outcome depends on it very, very strictly, yeah? Okay, now this decision also will be applicable to the decision of choosing the sample size. So after this, at the end of the lecture, we're going to talk about sample size, how big, how small. Too big is not good, too small also is not good. So the decision, it comes back to what kind of quality that you're aiming. Okay, how quality your data should be, and also what is the cost that you have, the resources. A lot of balancing work to do. Okay, step number 3, identify the inputs to the decision. Identify information needed for the decision, information sources, basis for action level, and sampling analysis method. So these are the continuation the details, I would say, the details of the decision that you have made. So once you have decided that the water quality is based on environmental water quality, so you pick that SOP, the standard operating procedure, and also the standard that you need to compare with, then only you define what are the details of it. Because when we want to analyze a certain pollutant, we must have prior information. If that is a pollution that happened, what kind of pollution? Is it from oil pollution, or is it from heavy metal pollution? Because only if you know the pollutants that you're going to analyze, then only you can choose the right procedure to collect, preserve, and analyze it. See? These are the things that you need to know beforehand, before you even go and sample. Yeah. So you can say step number 3 is the details lah, the detailed outline of step number 2. Okay, so continue to step number 4. Define the boundaries of study. Specify sample characteristics, define spatial temporal limits, units of decision making. So these are the so-called scope. I will call it a scope of work. Because why? You cannot study every single thing, and you have to define your scope. Reason very simple. Your resources were going to finish lah if finish and you cannot like do the whole thing accurately, because in order to define this scope, you also help control your budget as well. Like I said, financial matters. You need to plan well, otherwise you have not enough money for everything. So once you have received enough money, then you have to budget, and this is one budgeting that you need to do. You need to determine what are the boundaries of your research. Yeah, how big is the sample size, how big is your area that you want to study. Those are the things. Yeah, because it relates back to the cost and also decision making. Okay, number 5, develop a decision rule. Define statistical parameters, mean, median, specify action level, develop logic for action. Now let's start with the statistics first. Now I would say statistics usually they are pretty standardized, I would say. Now some of the people they might define those statistics in terms of mean, sometimes mode, but sometimes people use median. So I can't really comment in details which one is which and which one is usually used, because it all depends on the standard, the standard procedure that you're about to use. Like I said, there are many standards. Yeah, based on the medium, based on the pollutants that you're going to handle, and yeah, whatnot. So these are the things. But it's quite safe to say lah, from what you've learned before in science, usually people use mean, kan? Yeah, so mean. Mean, why? Because what? Average. Mean is average data. Usually people get some idea lah what are the average, but to complete this information, usually the mean value is reported together with standard deviation or standard error, because mean is nothing without that. Like for example lah, I mean the why Malaysia is considered high income nation. Oh, by the way, for you guys, I know you're poor. I know you are poor. I'm also not too well off, but Malaysia is considered as high income nation. Do you know why? Because in Malaysia, the richest gets richer. So they pukul rata, they calculate the purata. So poor people like us lah, the 90%, we are poor. But when you average with the rich people in Malaysia, we suddenly becomes high income nation. So I mean that is a reality lah. Yeah, not just in Malaysia, in other countries, many countries also have the same problem. Even in China, the so-called Communist Party also have this problem. Okay, so usually mean lah and standard deviation. Okay, the next one is specify action level, and then develop logic for action. Now, I'm not so sure what is defined here, but I would say these are the things that also defined in the standard operating procedure, because usually when we want to like um, have a sampling plan, usually is not open for interpretation. What I'm trying to say is that when you are going out to collect a sample and it is law abiding, usually everything is defined. There's no such thing as what kind of logic that you want to develop. It's only yes or no. Yeah, either the pollution happens exceeding the permissible level or below the permissible level. Yeah, so let's move on to step number 6. Specify tolerable limits on decision error. Set acceptable limits for decision error relative to consequences, health effects, and costs. Now, I would say these are the ones that is more towards interpretation. So once you have the data, interpret it. Now, usually these are the ones that are interpreted by statistician together with the data. Wait a minute. The data user. Yeah, So these are the ones because why? The data user knows what do they want. Statisticians have the numbers, so they need to compare. When you have the numbers, the pollution level, you compare with the acceptable level, because some of these so-called permissible limits or permissible levels, they come together with recommendation. So usually you will see this lah when you are looking at some official standard operating procedure for measurement, for analysis. Like for example, if a heavy metal levels exceeding the permissible level, they're going to elaborate lah. Okay, if it exceed by 10%, then what would going to happen? The probable effects, the health effects, how much you're going to damage, what are the risk factors, because the risk also depends on gender, age groups, and also so on. So these are what we call the interpretation of data. Oh, by the way, these are also in your, okay, later on, for those who are taking labs in soil, labs in water, labs in air, these are the things that you need to discuss, you know. Now, for those who also heard about my description, my elaboration on how to do a proper lab report, this is actually interpretation that carries 3 marks, 3 out of 20, a lot of marks. Okay, so last step, optimize the design for obtaining data. Select resource effective sampling and analysis plan that meets the performance criteria. So step number 7 is um, it should have been like I would say step number 7 would be the suggestion part. Once you have selected a method that you want to use to sample, to collect sample and to analyze, for sure at the end of it you're going to see some limitation. The good ones, okay, carry on and you use it for interpretation. But somehow, I mean, when you select a method and you go on, it probably might not turn out perfectly. Now I'm giving you example. Let's say if you want to collect the water sample, you want to collect water. No, I think I better use soil sample lah. Okay. Let's say if you want to go out and you want to collect soil sample, suddenly there is raining. Now for your information, if it rains too heavily, you cannot carry on with sampling. Okay, so what does that mean? That means that even though you have selected a standard procedure and you want to go and sampling, there are certain criteria or the certain rules that you need to follow. Like for example, the soil sampling. If it rains, you cannot carry on with the sampling. But you got to do this job, God. So somehow you have to finish the job. So then what? Then you have to come up with plan B, God. So what are your plan B? Are you going to sample elsewhere that is not raining, or you want to wait until a suitable time for sampling your soil, maybe non-rainy season? So these are the things that sometimes is beyond our control, because raining, who can control rain, kan? You can only like make decision based on climate. And for your information, climate nowadays also is so unpredictable. See what I mean? So if things happen doesn't go your way, if things does not go your way during the sampling plan, so these are the things that you need to optimize lah. Optimize mean modify the existing procedure, so that it achieve your objective. So these are the things that also applies lah in data quality objectives. So all 7 steps you can follow, but mostly they are like ever evolving. If things that are like non-optimized or not so good in addressing the data quality, like precision, accuracy, or repetitiveness, you can always recommend and you can always modify in order to help you achieve and improve the quality of your data. Yeah. So these are the 7 steps that you need to follow. Okay, so next part is consideration for sampling trips. So these are the questions that you need to ask first. By the way, these are not all the questions. So every student's lab, please, although the head or the director of the project needs to think of all these questions, but they are still human. They cannot see your problem. Let's say, for example, you as the head of the uh, water collection section. I mean, when you collect water, you know better than the project director. So if, let's say, the procedure or there are questions that the project director overlook, you must help the project director, which means that after this guy, now that we have two names, we have the candidates for project director. The next thing that the project director should do right now is identify the leader of small groups. The leader of small groups. So who are these leader of small groups? Coming back to this one. Okay, leader of small groups that involve in sampling. Kan? Okay, sampling also you have water, air, soil sampling. And then after that, you probably can appoint one person or several person from QA and QC team, because this QA and QC team are those that are directly under the sampling team, and they figure out what are the things that you should do to improve accuracy and precision. But before all that, okay, uh, Eza and Farah, maybe you want to appoint three to four person that will become the head of small group. Now this small group, we're going to in charge lah, the sampling of several different medium. These mediums are air sampling, water sampling, soil sampling, or maybe even one more if you like. Either you choose groundwater or marine water sampling, up to you. Yeah, depends on your project lah. Yeah. So remember, appoint formal person. You appoint lah. Yeah. After this, Farah and Eza. Okay. So this small group leader, you also need to help Eza and Farah to answer all these questions. Yeah. So these are like examples that you can follow. I won't go to answer all the questions, but if you have any question to follow up, to check with me, you can always check with me later. Yeah. Okay, now from all those questions, what was the missing question? Well, so far, the why question has not been answered yet. So when we look back at, okay, by the way, apart from the why question, the other question is, why do we even want to collect soil sample? So yeah, you want to collect all these things from different medium, and then how you're going to collect it. But the big question is, why do we even need to collect it in the first place? You see, this question will comes back to the objective. Why? What do you want to achieve? What is your objective? That is very important. Because why? From the objective itself, you will be able to limit your scope and better channel your resources to plan up what are the proper procedures for you to achieve that objective. So, question number one, what is your pollutant? Kan? Okay. Question number two, what is the pollutant doing in the environment? Is it contaminating the soil, or is it contaminating the water or the air, or all three? Because the worst case scenario is all three lah, then you have a lot of work to do. But if not, if the contamination is only contaminating the soil, then easy, address the soil pollution problem only. That's it. Kan? So you have to know lah, how big is your problem. Then only you set your boundaries so that you can better manage your resources. So these are the criteria for selecting a sampling plan. The objective, first of all, you need to make sure what is that. Number two, the variability. Is it what kind of variables? Well, of course lah. I mean, the variables depends on the objective. Sometimes the data user wants to know the changes of pollution over a long stretch of time. So that will be temporal variation. For spatial variation is how wide or how far the pollution has spreaded. So these are the space variation, or also time variation. So these are the things that might change and the variables that you need to change. Now, you don't have to address this if the objective does not require you to do so. No need, yeah? Depends on what is your actual objective. Uh, Oh, by the way, I'll jump a little bit. Objective, the baseline monitoring. So if it's a monitoring, then it will be easy job lah. So go to the site, collect sample, go back, analyze. No pollution happens. You just want to measure the baseline level. So usually this is what JS do lah. If no pollution happen, okay? But if the pollution does happen, and you want to detect the trends, so these are one of the objectives as well that could happen. Like for example, right? I mean, a year before there were pollution happen in Pasir Gudang. So right now they're still monitoring the trend, see if it comes back up or comes back down. And for your information, I know some of you are staying in Shah Alam kan, so there's no water. The reason I think you know because of the odor pollution, and you know why? Because the trend of this pollution happens due to human activity. It seems like every Sunday people pollute the river. So yeah, trend identification so that they can send drones and catch those people. And then the hotspot, so they want to see where is exactly the location that happens. So these are the things lah. Not necessarily they all will be required, but depends on the question. And then cost factor. This is probably the number one factor. No money, you cannot do anything. So you have to plan your sampling plan according to the fact, I mean the cost. Yeah, definitely. And then number four, non-technical factors. The other factors that are come in play is a sampling convenience, accessibility, availability of resource, and also regulation. So these are the factors that are not counted in technical side, but more of the policy and also circumstances. So, okay, so pollution and approaches for environmental sampling, representativeness. Okay, one more time lah. Okay, the definition of representativeness is a measure of degree to which data accurately and precisely represent a characteristic of a population, a parameter variation at sampling point, a process condition, or an environmental condition. Long story short lah, the representativeness means it it actually okay, how to say it? I mean this criteria is defining whether or not the sample that you collect is indeed from and represent the sample at the site. You see, this is a very important criteria because even when you collected some sample from the site, the so-called site that you want to study, doesn't mean that it represented due to several factors. Factors such as you are not sampling wide enough because the pollution may have happened like very wide area. So that probably do not represent the entire story, kan? Okay, that's one. And number two, even though the pollution happened at the site, you probably have come at a very late stage. So when I say late stage means things have changed. These changes is quite normal because why? When there is a release of pollutants, they don't stay put. They probably move with the direction of environmental element, such as the wind. Okay, the wind may going to blow it away and carry it somewhere else. Or number two, rainfall, because when rain comes down, it may going to dissolve and leach some of these pollutants into the soil, or it may carry it above ground as a runoff. So there are many things that may change the nature of the sampling, and representativeness is one factor that is questionable because usually those people who do not plan too well, they may not get the true picture. They may not get a true picture of the pollution because of this problem in representativeness. So I hope you understand why this is so important, especially environmental sampling plan. Yeah. So to give you an example, the representativeness in solid sample. Now, in terms of solid sample, I would say the representativeness problem is not so apparent because why? Solid is relatively immovable. Like for example, the soil sample, because they have their heavy weight, they're dense, okay, the dense nature, most of the time they were going to move according to the gravity, move downwards lah, until they reach the ground. So when they reach the ground, then that's it. They virtually don't move too far away unless you have a very strong wind and very strong, very fast flow of runoff or rainwater. So these are the things that usually do not bother too much like in terms of representativeness. So you can see like these kind of soil, they may going to deposit over time. So over time, guys, so you may have some layers and layers of different characteristic of soil sample or solid sample. Yeah, not necessarily soil. It could be any solid that is heavy enough to fall down and stay put. So different depth lah, they represent different timeline. Yeah. Okay, sample preparation process such as subsampling, mixing, grounding, sieving, particularly important for representative samples. Okay, now coming back to the soil samples, the proper way to collect soil samples, we already have a standardized method. Like for example, in order to collect soil samples, you have to use an instrument called auger. Don't worry, later you will see it. Okay, it's an instrument that is called auger. You have to use that to collect a vertical profile, a profile of a soil from the surface until 30 centimeters deep, and then only after that, then you mix it up and sieve and so on. Now, why are we doing all this? Is because we want to collect a soil sample with a known profile, with a known depth and also dimension of it. And I'm sure you know that soil samples, they vary so much, especially from the first 10, 30 centimeters. Because on top, you probably can see a lot of leaves, dead leaves, some coarse matter, more stones, compared to the bottom 30 centimeter. Whereas at the bottom, you probably can see a bit more sand, more refined particles, very fine particles compared to the top ones. But then which one is which? Yeah, is the top one represent the soil sample or the bottom? The answer is they are all representing, which is why in soil samples, right, after you have collected the entire and the entire profile, the entire profile of the soil, then you have to mix it up, remove the particles that is greater than a certain gravels or large object. You have to remove it. Then after that, you have to sieve it to 2 mm. After 2 mm, then only you are going to divide it if you wish, because some soil samples, there are a lot, you have to make it smaller, but before that you have to mix it well first. Yeah, so these are the things that usually these are the procedures lah. Yeah, the second point, the procedures used to homogenize. Once you have collected solid samples that are not homogenized, you have to homogenize it, and usually the second point is the one lah. So sometimes it's not just for soil sample, it also like applicable to any solid samples that also need the same treatment. Okay. Now another factors that I probably have said to you earlier that define the representativeness is whether or not the pollutants have spreaded. Now, as you can see from here, this is a pipeline. You can say that this is the so-called the source, the what is it? Ground zero, if you wish to call it. This is a ground zero, the point where the pollution started to spread. So you can see, like, of course lah, this darker area with A, B, C sampling point will have the highest concentration. But due to the spreading of this pollution, it could have been spread into wider area, into D, E, F, G, H sampling point. So it depends, okay, whether or not you get the right sample that represent the site. It depends on your objective. You can also sample all the sampling point, of course lah, if you can. But you see, if you're too poor and you only have a certain amount of money, when probably you can you only need to know where is the the pollution level in ground zero. So ABC lah, this is the 3 points. However, if your objective requires you to sample the entire temporal, the entire spatial distribution, then the entire thing have to be included. Because why? It depends on your objective and the representativeness of it. If it requires the the temporal distribution, the spatial distribution, all of the sampling points need to be included. Okay. So what about the air sample? Okay, just now soil sample, they fall down, they stay put. Easy. Good. But what about air sample? Now air sample is quite tricky because why? Air, as you know, they don't stay put. They're probably going to move according to temperature, according to wind direction. So the representativeness of air sample is probably kind of hard to get. And you have to really define whether or not your sample is representing the the conditions that you wanted. Yeah, because these are the factors that can like alter the representativeness of air sample. Okay, factor number one, meteorology. I'm sure you know what is that. Meteorology is affected by the so-called the what they call it in Bahasa Melayu you call it cuaca, like in English we call it the weather. Yeah, the weather. So in terms of weather, I'm sure you'll hear about weather report in news card. So number one, they're going to tell you whether it rains or not. Number two, with the wind direction and so on. So usually the wind direction is the biggest culprit because if it blows, if it have like strong wind and they blow and they spread very fast. But there's another thing, the direction. Where does it blowing? Because why? Because from the point source, okay, the source where the pollution is released, the direction is even more important. Because where, I mean, when the direction is known, then you probably can find the pollutants along the track of the direction. Yeah. So these are the things that you need to have predictions yeah. That is why in sampling plan for air sampling, before you even go to the site, you must tell the meteorology parameters, such as what is the estimated temperature? What is the estimated temperature on the day where you want to take your sample or during the entire duration of your study? Yeah, because in Malaysia we have season, not really the four season in temperate countries, but we have rainy season, we have monsoon, we have rainy season, we have dry season, and temperature affects it really. Now, not only the temperature, but also the wind velocity and also the direction. As I told you just now, monsoon, the direction of wind changes greatly. Yeah. Okay, number two. Apart from that, it's also affected by topography, the shape of the land. There are some reason why in the west coast we don't receive any more rain. Now this is not the time where I want to teach you geography. I'm sure you learn it in secondary school, but I'm sure you know that the reason why the west coast of Peninsular Malaysia does not receive too much of rain and cause flooding is because of the Banjaran Titiwangsa. So what does that mean? That means some of these wind direction are also affected by the shape of the earth. If you have a very high landmarks, for example, not just hills, yeah, landmarks. I mean buildings. If you have large buildings, that also may be factored into the representativeness of the air sample. Because why? It may change due to some blockage of the physical structure on the surface. Yeah, they might spread along with the lines or the structures on the surface, not just the hills. Yeah, sometimes big buildings also factored into the topography. So what can I say about those teams that are involved in air sampling? So this is for the people who is about to deal with air samples. You have to first determine the weather patterns. So I'm sure you know the weather patterns. You can get it from Meteorology Department of Malaysia. You can get it. The current data is free. That means if you want the data today, you just go to the website and catat. However, if you want to get meteorological data from the previous times, like 1 month ago, 2 months ago, or maybe several years ago, you will need to pay for it. So listen carefully, yeah. If you want old data, you need to pay. New data is free. Yeah. What about future data? No, they cannot predict weather. They probably can predict weather maybe several days before, maybe maximum 1 month before. Um, but I think that is good enough lah. Nowadays, technology is very good in predicting weather. So why predicting weather is so important? Number one, your sampling trip. Can you go or not? If it rains, of course, you cannot go. You have to plan somewhere else. And one more thing is so important is your air sample, because you also need those meteorological data to actually know whether the location of collecting air sample is okay or not. Yeah. Long story short lah, for those who are involved in uh, air sampling, just get to know your weather patterns lah, temperature and wind direction, and also wind speed as well. So these are the examples lah, yeah. How does variability change lah with water samples? Okay, now water samples also is very mobile. So it's as tricky as air, although it's not as tricky because water flows much slower. But there are also factors, similar factors that influence the variability. I would say temperature first, lah, yeah. Because why? If temperature is getting hot, there are draft, there are direction of this flow. The current will going to flow upwards. If it's hot, it will flow up. If it's cold, those water will tend to sink to the bottom. Now, if you are taking water sample from a lake, a stagnant lake that does not flow, these are probably the things that you need to consider as well. Stratification. Stratification means different layers or different strata, as we call it, different layers with different characteristics due to the variability of temperature, for example, or even depth. Because we know the deeper it goes into the lake, the colder the temperature. So when it's colder, definitely the characteristic of water also will be slightly different, and that may affect the data that you're about to have from your sampling. Yeah. So these are the variability that you need to consider. Let's say your objective of your sampling, okay, the objective of your analysis is to determine the overall lake temperature, or no, the overall heavy metal concentration in the lake water. Then you might going to ask yourself, how much money do you have? Because why? If you say overall heavy metal concentration, that means you have to sample from the bottom, from the top, in the middle, the side, everything. Because only that way you can collect water sample from the entire section of the lake, and that can be used to represent the entire water quality of the lake. You see, very tedious and very costly, kan? That's why, okay? That is why usually when we talk about water sampling, we don't tend to bother about the lower strata of the lake for some reasons lah. I mean, some of the objective might want you to look at the bottom of the lake only, not the surface of the lake. So it depends on which one of the objective that you want. Yeah. Okay, what about the representativeness of the biological sample? Now, this one, I would say I probably don't touch too much lah, because this is probably more of ecology thingy that, okay lah, I will just talk a bit. Now, biology, we're talking about animals or plant. Now, plant, of course lah, plants don't move anywhere. I'm talking about the trouble when you want to sample animals or insects that moves around all the time. Now that is because they move based on a lot of preference, and as you can see right there, there are 5 of them. Different species, they may spread differently, because species also determines all the feeding habits. Let's say some areas where there are predators, they might be having a bit more of a certain species, a certain species than the other region with predators. Maybe size as well, because size also determines a lot of things like the likeliness of being a prey to the predators. So that also affects the heterogeneity. The gender, I mean, sex is also for that. I mean, gender for humans, sex for the animals and the insects, and also the mobility. So these are the factors that also can change the representativeness of biological samples. But the beauty of it is, based on these heterogeneity, biologists can also study all these other factors related to biology. Now, I have to say, in environmental sampling, we are not going to touch things that significantly for biological samples. Yeah, for obvious reasons, yeah. We only touch about environmental pollutions as well. Biology, we do touch a little bit, especially in water, but not so much, yeah. So I think this one I'm going to skip. Now let's check how much time we have. Around 30 to 40 minutes, and we still have around a lot of slides to complete. So I recommend we don't stop, yeah. Okay, we don't stop and continue, because I really need to finish this slide. Okay, if you need to do something else, okay, never mind. The session is recorded. I will upload it later, but I'm going to carry on with this lecture. Okay, so next one, types of sampling: non-probability samplings and probability sampling. So I'm going to look at it. What is non-probability sample? It is a sampling technique that is based on the convenience, okay, the ease of access. So this one, uh, you can call one of them is probably random sampling layer. So these are the technique that are not very systematic, I would say, the non-probability ones. Yeah, because those are like, you can do the sampling but based on judgment. Okay, so it can be purposively sampling, that is judgmental sampling. Convenience is based on circumstances, because like for example, there are some sites that you cannot go in and have a systematic sample, so you have to go to a place where it is most convenient for you to collect samples, like the side of a lake, the side of a river. It's not convenient for you to go to the center of the river or center of the lake, kan? Because it's not convenient. So these are the examples, yeah, for you to have the non-probability sample. You choose who you think should be in the study. So these are the judgmental ones, like just now, what we have seen just now, I mean the pollution. Because most of the pollution happens, and we have some knowledge from some background studies, yeah. Like for example, you know that a site have a factory, and that factory most likely is the point source of the pollution, or ground zero. So if you want to determine what is the concentration of the pollution in ground zero, so you just make a sample near the factory. No need to go too far away, no need to go to any direction, yeah, if only you have the information. The other example is that, let's say there is a site, there is a place that you know exactly the location of the X landfill, for example. Now, landfill most likely is the point source of the pollution. So if you know which area is the X landfill, you just need to go there and do sample around that area. No need to go to away from there. So that is why you need sampling plan. You study first, and then you know where are the areas that you want to do your judgmental sampling. Or also quarter sample. Not so sure what is quarter sample is like. Never heard of it. Um, Probably we'll come back to that later, yeah, if you have any question, because I haven't heard about quarter sample before. Okay, now, so following to what I have explained to you just now, judgmental sampling. Okay, now that is about a selection of sampling location based on professional judgment. I would say not professional, I would say informed judgment. Informed means you have prior information. Like I told you just now, you know the location of that X landfill, you go there and pick your spot. Yeah. Using prior information on the sampling site, visual inspection. So if you don't have any like prior information, you can look for it. Visual inspection, like leaks or discoloration. Like for example, oil. What is the color of oil? It's black. If you are analyzing the presence of oil, you just look for any area that is dark, that has some oily appearances, or maybe some smell of oil. That is a place that you need to start. Not just that place, maybe that is a starting point. Okay, so a lot of information you can use, either use a smell, use your visual, or whatever information that you have. You see, sometimes touching also, you touch a certain soil sample, okay, oil, because why? Oil is slippery kan. One example. It is allowed when budget are tight. You see, that is why it's always the same reason why we need to pick this out. Judgmental sampling is allowed but not encouraged lah, because it is not systematic. You judge, you see, sometimes human judgment also can be wrong kan? Because you may have some skewed information, so your also be skewed. So the only way you can ensure that unbiased information is that you sample the entire thing. You have a systematic sampling. Yeah? So you can only do that lah when you don't have enough money and you have to get the job done. So okay lah, yeah, you can still do it if you have a very good information beforehand. Or number two, quick qualitative response is required. You see, like for example lah, during this COVID time, if you want to have like a very comprehensive, very complete study, after you finish your study, then possibly 1 million people already died. So you have to wait lah. I mean, you have to wait. Uh, the quality that you're about to achieve and also the consequences, because by the time you finish the complete study, yes, your study is accurate, correct. Then what? People already died. So sometimes when you need a quick decision, you also need a quick analysis. So by saying quick, some quality may be sacrificed. So okay lah, if it means to save life, then that can be tolerated. But of course, in no way this judgmental, I mean the data from judgmental sampling will be relied solely. Usually we're going to have a quick analysis. That will be what we call a survey. A survey is meant for having a quick information but not so accurate. And in order to complete the entire process a second time, like you have to run and you have to analyze the second time. So only the second time, only then you have a general idea where is the pollution is, and then you have a very systematic way of analyzing it. Yeah. So judgmental sampling is not encouraged, but it is allowed under these two situations. Now about the second one, non-probability sample. Let me show you all the points first. Okay, probability of being chosen is unknown, cheaper, but unable to generalize potential bias. So these are the so-called the weakness lah of non-probability sample. And one very good example of this kind of sampling is judgmental sampling. Okay, so there's no randomization, and then the sample protocol also is solely based on human judgment. So these are the things that are for survey only. If you want to survey an area, it can be allowed. Now the only problem is judgmental sampling kan. There is a big risk lah. If you want to use it in court and want to charge people, usually these are the sampling that we're going to jeopardize the quality and also the robustness of a data. These data will always be questionable because it's based on human judgment, based on what you determine that. So it's not unbiased lah. So that is the problem, yeah. And then the level of confidence cannot be quantified. So usually the data coming from judgmental sampling is always questionable in terms of their accuracy lah, yeah. So what about the other one, the probability samples? I would say if you want to have a proper sampling plan and your budget is not too tight, you always pick this one lah, yeah. Because this one will always be ensuring that your data is robust, It's not biased, and that is very important, especially when you're handling a court case. Okay. So what is random sampling? Okay, each subject has no probability of being selected. So it's kind of like each of the sampling point that you pick is quite even in terms of the probability of being chosen. Now, that actually will contribute to unbiasedness, not bias. That is important, because why? When people ask you whether you're biased in choosing those points, because why? If you're biased and you choose only the points that have pollution, then most likely the data will be skewed to high pollution. So that may not be representing the entire situation in the site. So that is why random sampling is much preferred yeah, because it removes the human error. I would say it removes and it avoids biasness and also human error that may occur in a sampling plan. Okay, number two, it allows application of statistical sampling theory to results to generalize and test hypotheses. So only if you have a probability sample technique, then only your statistical analysis will be valid. Remember just now, the entire team consists of one small team that looks at the statistics. So yeah, you need to have like a proper sampling plan in order to have that. And so yeah, what I can say is random sampling is one of them. Random sampling is one of them. Yeah. So the conclusion is always choose probability samples. Yeah. Even if you have a choice, you always choose probability samples. Judgmental samples is only due to a certain limitation. And because of their consequences in data quality, usually we don't recommend judgmental sampling. Yeah. So to ensure representativeness and precision. So these are the examples that you can use for probability samples. Simple random sampling, stratified sampling, systematic sampling, multi-stage sampling, and cluster sampling. All of which you don't know until you can see the picture. So let me see. Simple random sampling. You got the points over here, but I'd rather choose the picture. So as you can see from the diagram right here, if you have a piece of like in a square box is where the site you want to study. So simple random sampling is what you can see right here. It is randomized. It's not arranged in a systematic manner, but as you can see, the sampling points is reasonably spread out and they are not concentrated in one spot. It is random, but it's reasonably spread out. So this is one example of simple random sampling. Now, what about stratified sampling? Now, stratified sampling, they may have a little bit of judgment inside here, but still it is like quite acceptable in terms of the statistics. Yeah, because if you look at the diagram of the here, so this is example of a stratified sample. Now, in this stratified sample, one site can be divided into several regions that represent several different parameters. Okay, now for example, this piece of box may represent uh, different elevation, different height of, different elevation in terms of the land. Now, some of this area, like for example, K1 may be considered as highland. So highland, of course, they can stratify it and they can collect all these samples that represent the entire population in highland area. What about K2? K2 for possibly K2 may be from lowland area. So these represent from lowland area. What about K3? K3 may be some even lower than that, maybe swamp area. This area uh, is inundated with some water, swamp. So these probably can be stratified based on the geography. Okay, it could be stratified based on geography. It can also be stratified due to human some anthropological factors. Like for example, this area may be as simple as they are fenced up. Kan? I mean, if they're fenced out, of course, it limits the movement. So that also can be used for stratified sampling. But if you look carefully, even though they are stratified, the distribution of sampling point also quite even and is not biased to a certain area. So that you have to remember, even though stratified sampling looks very biased, but actually the distribution also is quite average and quite uniform. So that that actually removes the biasness, yeah, and ensures the variability of the sampling. Now I think this is everyone's favorite, like, and it's also my favorite, systematic grid sampling. What you do, you take a map, you draw boxes, and every box in the middle you put one sampling point. End of the story. You can say this is one of the easiest, but to implement it, I wouldn't say it's the easiest, because what is flat? If you look at Earth also, some places they are flat, some places they are not. And there are some places also that you cannot go. Like for example, there are some places where there are rivers. You can't sample soil sample inside a river bed. Right? That is considered a sediment sample, not even a soil sample. So this can only be applied if you're talking about a very vast piece of land, for example. You can do that, yeah. It is easy because it's easy to do on paper, but in reality, not so yeah. And most of the time, you're probably going to resort to systematic random sampling, because on paper you can draw box, but when you go to the site, some of the spot you cannot take soil sample, so you have to adjust a bit, move a bit to the slightly to the left or to the side. Then you have this systematic random sampling, and again, the spacing and also the distance between each of the sampling points is reasonably uniform so still okay. It is still okay in terms of the representativeness of the site. Now, composite sample is, let us read. Okay, let's read the content. Okay, if sampling cost is much less than analytical cost, which is typical for many trace sample, composite sampling is a valuable means in cost saving. So why do we want to composite the sample? One of the reasons is to save costs. Now, to begin with, composite sample in terms of soil science is very common. Why? Because because the soil samples can be mixed much more easier compared to water and air sample. Like for example, if you collect two soil samples in two different spots, and those spots happens to be within 20 meters apart. 20 meters is not too far away. 20 meters is quite close. Now, for any two samples that are sampled at less than 20 meters apart, it can be considered as one same soil sample. But it's not the same yet, right? Because you haven't mixed it. So in order to analyze one small area within 20 meters, you have to collect a few samples. You have to collect a few buckets of soil samples, mix it together to become a composite. So this is what they meant by composite sampling. Because instead of analyzing every single data point, you can only analyze just one composite sample that consists of all the sampling point. In other words, the data quality probably will not suffer too much, given that they come from the same area. But the big advantage is, instead of analyzing many samples, you can just analyze one, and you save time and money doing that. So the question is, why not? If the variability is not really a big importance, or if the area is known to be similar, so why not make composite? It can be accepted. Okay, now furthermore, let's read. If the goal is to estimate the average concentration rather than variability, so yeah, like I said, if the average is needed, then okay, usually that will happen if there is the plan. Okay, the objective is just to survey or just to determine the baseline. Baseline means no pollution. Okay, no pollution, of course lah. Why bother so much and make average? But if the objective is to determine where is the spread, how does the contamination spreading, then composite may not be that good lah, because you want to know precisely where does the pollution migrate. So if possible, every single meters or inch of soil area that you want to determine, so that you know, okay, the changes of pollution from the point source towards the pristine environment. So it depends lah, yeah. If you're monitoring pollution, if you're monitoring pollution level in a precise manner, in a very quick manner, composite cannot be used. You have to do like very precise sampling lah, yeah. Search sample is, the goal is to find out where is the hotspot. So this is like, you don't know, okay? You don't know where is the point source, and you just like main tabo lah. You just want to find out where exactly is the point source. So search sampling, usually we're going to utilize grid sampling because we don't know where is the point source, right? So you just put a map and then map out every single area you want to have one sampling point. So it has to be systematic grid or systematic random sampling. And then from the outcome of it, you kind of know lah, okay, which area have higher concentration. Then that area possibly might indicate the point source might be from there. Now, when do you need search sampling? Is when you don't know exactly where is the source of pollution. If you know, then no need lah. You just focus on the point source. But if you don't know, or you want to have a survey of the entire spreading of the pollution, then search sampling is needed lah. Now, transect sampling is another variation of systematic grid sampling, but it follows the transect lines. That means sometimes, like I said, there are places where you plan to go, but you cannot go due to the geography, or maybe due to some difficulties in accessing that site. I think the entire explanation I already mentioned earlier, so I won't going to mention it again. I'm going to, I don't know, there is no lines that I can, now, what I can explain to you, the transect sampling is that, let's say if you have a grid sampling and there are certain points they cannot go, then you have to follow along the lines where you can go. I mean, the very the usual examples of transect sampling is due to different heights in terms. I mean, let's say in the map you want to sample the soil in a lowland area. Suddenly you have a cliff. I'm not talking about slope, a cliff that directly goes up into the air. You cannot the cliff. So you possibly you might need to satisfy by going to the cliff or around the cliff, collecting samples from lowland area. That is the best you can do. So the lines between lowland and highland area will be the lines of your transect. Okay? So that is geography, highlands and lowlands. Now what about the river? River also is another thing. You may want to collect soil samples along the river, along where the river flows to. Can't go over the river. If the river is too deep, too big, you cannot go over on the other side. Well, of course you can with boats, but I mean, these are the limitations that you can do. Yeah. So you might going to discover that this transect sampling relates closely to the stratified sample. But this transect sampling is more applicable to geographical or maybe some physical limitations that you may have in accessing the sampling site. Okay, how much time? Still have 20 minutes to go. So I have around, not much. After this is more about statistics, estimating sampling number, which I think you should have learned. But before that, I want some feedback from you. Just curious lah, how many of you have already enrolled and taken statistics? Have you all taken statistics here?
Statistics is this sem.
This sem, yeah. Okay, so I'm going to leave the statistics to your statistics teacher lah, because why? I'm not good in statistics anyway. But I need to tell you one thing lah. In sampling plan, statistics is very, very important. And one important thing to do is you count your sample numbers, because there's always one question: how big do you need to sample? How big is your sample size? Because if can, kan, I just want to go to the sampling site and take just one sample. Betul kan? Why not we just take one sample? Why do we need to have like 3 samples and then we have to go to the other areas and sample another 3 samples? Because it all comes down to statistics. And I'm sure you know that. So with that, I will just come down here and show you the formula. I'm sure you have seen this formula. You should have seen this formula and you will be practicing in statistics subject. So that's why I won't show you how to calculate. I'm just showing you this formula, and N is what we want to know. Usually N is what you should report. And after this, when you all go to FYP project, whatever that you want to do, whatever project, please include statistical analysis. Okay, from your batch onwards lah, please. Okay, because the previous batch, they never bother about sample number, which is, if you don't know how to determine sample number, seriously, you're not qualified to become anybody in the field of environmental protection, seriously. Because sample numbers determine whether or not your data is robust or not. Okay. But of course, like I said, we want as accurate as possible our data, and usually the accurate data comes from a big sample number. But the problem is big sample numbers require a lot of money. So then what? Then you have to balance lah. Based on the money given to you, the budget that you have versus the accuracy. I mean, the accuracy and precision acceptable for your project. See, this is very subjective too, dah. Yeah. So that is why you have to use this formula lah, and you calculate what are the sample numbers that you need to do in order to have a confidence level within 95%. You can have like 99%. Can you have 90% confidence level? The answer is big no. Because 95% confidence interval is probably the minimum that is acceptable by law enforcement. If your confidence level is less than 95%, then habislah. You cannot use this data because nobody will trust the precision and accuracy of your data. So that is why, I mean, this 95 confidence level is represented by this sigma. I believe this symbol means, so sigma is placed under here, down here. So you have to put it as 0.95. N is your sample size that you're about to calculate, and then this is sigma, I think, and this is, I forgot what is this symbol called, but you know how it looks like. So the variance, the population variance, is determined by this sigma level, so sigma square. Now this one, it depends on the pilot study that people have done before. So this is the variation that representing the population. So this data possibly is known, and this is predetermined. So 0.95 versus the variability that you should get from literature, then only you calculate your sample size. You see, this sample size will be small if the variability is small also. So you can have like maybe 3 replicates during sampling if it's permitted. But I can tell you straight away, it's very rarely in any sampling plan you collect less than 30 samples. It's usually more than 30. You see, there is a reason why, but I think I'll show you later. I have a certain slide that shows you why. Why always when you go to any field trip for sampling, you will have to get 30 sample or above. Now, not only 30 sample, not only in science and technology, sometimes if you have friends in social science, when they do any survey with questionnaire, they also say must have 30 feedbacks or above. Now 30 also is minimum, yeah. Sometimes the 30 also is not good. The good ones, okay, I myself conducted such a survey. You know what is the best number, the best size to have a good variability. I mean, to have a very low variation data with a very stable and accurate data. My sample size during that time was 300, not even 30, 300. Then only you have a very robust data. But you see, you cannot have 300 samples in the environment, kan? So that's the question. You have to balance lah, yeah. Minimum usually 30, but the best is as high as possible. Depends on how much you can pay. So you can like test and everything, but I will skip